we have a trapezoid here, and we have a half circle. The three sides are tangent to the circle, and we are given the side lengths 8 and 6. We try to find the length of the base, CD. Alright? Why don't you try to solve this problem? Pause the video if you need to, and then when you're ready, let's continue to the solution. Now, whenever you have a circle and a tangent line, what you want to do is to make the connection as we do here, connect the center of the circle to the tangent points, and the radius here would be perpendicular to the tangent line. So in other words, OZ is perpendicular here. Yeah, it's 90 degree. This is 90 degree here. This is perpendicular. All right. So you try to find the base CD. So you may think maybe use Pythagorean theorem. In this case, you have right triangle here, right? In order to find the length, you need to find what is R and what is the size here, right? And that could be one direction you want to go. But there may be many steps involved. Now, either another way. Yeah, why don't you think about it, pause the video again if you want to. In the meantime, let's recall that if you have tangent lines from a common point A, here in this case, I have two tangent lines, we claim that AB would equal to AC. Why is that the case? So here, again, according to the property that this is the right triangle here, we have radius R, which is common here, yeah, and we have common hypotenuse here for the two triangle. So we claim that these two triangles are congruent with each other, right? Because R, the sides are equal, hypotenuse, and then this is the right triangle. So we have ABO triangle, yeah, ACO triangle, they are congruent. So what we get is AB equal AC. Okay, so two tangent lines and then the lengths are the same. And not only that, this is congruent, so which means this angle here is equal to each other. Here, this angle equal to each other. All right, so that's something that we're going to use for this problem. Let's go back to the problem. All right, so here earlier we said that common point A, this here, so there would be two congruent triangle here. So let's make the connection here. Yeah, so congruent triangles, AXO, yeah, AXO is congruent to AYO. So in this case, I'm going to have this angle here, alpha. Let's say this is gamma. Alpha would equal gamma. However, in the meantime, we notice that AB trapezoid is in parallel of CD. So what you have, according to the basic theorem, that alpha is equal to this angle here. This is beta. So alpha would equal beta. Now, from the above, you will know that alpha would equal beta would equal gamma. Now, when you look at the other triangle here, let's highlight it here. Yeah. So when you look at this triangle here, we have just shown that beta equal gamma. So which means isosceles triangle, good news. AD is equal to OD, which means OD equal 8. Similarly, for the right hand side, you would use similar logic and prove that this is actually 6. So the length here we're looking for is actually 14. So the length of CD equal this. All right. So in summary, we use the basic property of tangent line from common point A to prove this congruent triangle, so that beta and gamma are equal to each other in this diagram. And we notice that the isosceles triangle here, and then from there we say this is 8, this is 6, and the total is 14. All right, so that's the solution to the problem. All right, so this represents some common technique. Whenever you see tangent line to the circle, you make the connection, add the auxiliary lines, and then you get perpendicular, and then from there you can use other properties to solve the problem. All right, it's quite a typical approach. I hope you enjoyed the video. Please like, share, and subscribe. Thank you.